Please welcome to the stage your host, Spring Developer Advocate, Dan Vega.
Hello, and welcome to Spring Spotlight at Explore 2024. My name is Dan Vega, Spring Developer Advocate and co-host of the Spring Office Hours podcast, and I'll be your guide through this morning's session. Whether you're joining us here in person in Las Vegas or online, over the next 3 days, you'll see a packed schedule of sessions around the Spring framework in the Spring Theater. I want to get right into it, but first, please use the Spring1 hashtag in all the great social media places. We also have a Discord channel where you can join in the conversation. You'll find this located in the sidebar of the live stream at spring1.io. And if you're here in person at Explore, be sure to check out the Tanzu platform talks in the Modern Apps track. We're also hosting several Meet the Expert roundtables where you can talk directly with Spring developers and experts. With that, I'd like to introduce the General Manager of the Tanzu Division at Broadcom, Purnima Padmanabhan.
Thank you, Dan. Hello, everyone. It's great to be here again. This is my second time round at Spring1. So welcome to all of you who are here, as well as a big welcome to everybody who's online. So, Spring, still, as far as when last time I checked, still the leader in Java. #1 Java development framework by far. And it is not just thanks to us, right? We are curators of Spring, but it's really the power of the community that makes Spring so powerful and Spring #1. And it shows in the enterprise workloads. Still 46% of enterprise workloads use Spring. So when we look at what does Spring touch in terms of our human lives, that is what is really powerful about it. Every walk of our lives are touched by Spring-based apps, whether it is defense, whether it is transportation, healthcare, banking, finance, entertainment, name it, and Spring is used to develop those mission-critical, important apps that touch our lives. I'm going to give you a few examples, and you'll hear more during this talk. Barclays, banking, and what they have done is they are a big Spring user. They have built their applications in Java, and now their Java developers wanted to start using Gen AI to light up their apps with more capabilities. With Spring AI, their Java developers were simply able to plug and play Gen AI-based models and capabilities and add chat-based approaches to their apps without having to deviate from their regular programming framework. So truly, kudos to the power of Spring AI. Fiserv, millions and billions of transactions go through Fiserv, financial transactions. And what they have done is not only built on Spring, but they use Spring as a connector and a cloud gateway that allows them to connect Spring apps to other applications within their ecosystem. And then Datev. I won't talk much about it since you'll be hearing more from them and James. A cooperation of tax consultants, cooperative of tax consultants, and they have completely modernized platform engineering practices with Spring. So let's go into, okay, you've got this fantastic development framework. You're building applications at scale. But how do you get your Spring apps to production? And this is one stat that shocked me. The difference between who we call leaders and laggards in the industry is spectacular. While leaders can get out an app from code to production in 1, at the most 7 days, laggards take 6 months to a year. So even though the code is ready, by the time it is available in production, there is a huge time lag. And that is what we are here to solve as Tanzu. Tanzu supercharges Spring, right? We make it possible for companies and enterprise like yourselves who write applications in Java and Spring to get them out in production at scale. Tanzu platform accelerates application delivery at scale by helping organizations develop, operate, and optimize applications. and deploy them to either Kubernetes or Cloud Foundry, private cloud or public cloud, and maintain and manage them. So what it means is that you no longer have to worry about just building apps, but you no longer have to worry about, okay, I've built this app, how do I get it to production? How do I scale it out to my users? You can do that now with Tanzu platform. So Tanzu and Spring form a very powerful combination. From a developer perspective, it's very simple. You already have Spring Framework. And then Tanzu platform offers a simple set of operations to the developers. Hey, take my code and convert it into a container, bind it, deploy it, and scale it. And then the platform for platform engineers gives a way to curate the right environment, the right clusters, the load balancers, the high availability, the resiliency, so that when the application lands on an environment, it can operate at scale, and more importantly, it can continuously be updated with the famous components that was pioneered from the Cloud Foundry days of being able to repave infrastructure, repair your applications, and rotate your credentials. So that's what Tanzu does, Tanzu platform does. And let me give you a quick example, right? You have an application team that has written code, but once you've written code, the simple build operation takes that code, looks at the conventions, looks at all the dependencies, looks at all the CVEs, and then we make the magic happen to give you a secure container build. Once the build is done, binding to external services, in fact, we were just talking to a customer, Datev actually, binding to external services is an important part. No application is an island. You need data services, you need caching services, AI services. And so Tanzu platform makes it very easy to bind to these external services without worrying about credential management. It's the credential management that often causes problems and causes security issues. And it also includes over 200 plus open source packages available to you to bind those. Then it comes to deployment. And often you deploy for you want different patterns. Maybe you want just a single stack, you want a highly resilient stack, you want HA, you want multiple availability zones, you want load balancer configurations to be changed, you want blue-green deployments. All of that can now be just given as a simple command without you having to worry about the underlying infrastructure because the platform can manage it for you. And finally, when you're ready to scale, this is not one time. The platform is truly dynamic. It understands the needs of the Spring applications, and it can scale based on those needs. So that is what Tanzu platform offers, along with all the operational capabilities that is needed for platform engineering. So what I say is Tanzu platform is rocket fuel for Spring. And not only do we give you the platform, but we also give you a set of consulting services through Tanzu Labs. Whether you want to adopt Spring, move to Spring, upgrade Spring, build on Spring, we cover it all. And we are here to support the community to truly immerse itself in Spring. So with that, let me just tell you a little bit about what's new in Spring. And you'll hear a lot more about this in the rest of the session. Many of you have deployed Spring apps, but often you don't know what is the state of the union there. So with platform, you have got the ability to do discovery of your Spring apps. Not only that, understand the state of its security, the CVEs, and more importantly, tie it back into your CI/CD pipeline with pull requests so that you can automatically update your Spring environment. A dashboard that tells you how compliant you are, and a set of libraries for FIPS compliance and PCI compliance that you can incorporate into your application. And finally, when I said it's rocket fuel for Spring, when you run Spring on Tanzu platform, we have made sure it runs 5x faster. Faster startup time, faster boot time. And so truly, the pairing can accelerate your applications. Now, the other thing that we have done is Spring AI is getting a lot of momentum, and we have paired it with Tanzu AI. Now, this is a sneak peek. You will hear a lot more announcements on Tanzu AI. So Spring AI lets you build these AI/ML applications without having to worry about hard coding models. You can stub out the models and then do late binding connections. And what Tanzu AI does is it allows you now to connect to these models in a secure way that is governed, that is metered, that has monitoring, right? A lot of times customers tell me, I need metering on these and I need gates on how my teams are connecting to the models. You can do all of it with Tanzu AI. So there's a lot more that we are going to be talking about Tanzu AI. Looking forward to that. With that, I wanted to also mention that we have detailed sessions. So tomorrow at 2:15 at Level 4 Delfino, we are going to be talking about the platform, but also doing a full technical demo so that you can see it in action with Spring AI as well as the Tanzu platform. So, thank you.
Wait, before we get started, you know what we gotta do. Obligatory selfie, everybody. Okay.
This time with rabbit ears.
Yeah, this time with rabbit ears. Okay, pretend like you're happy, everybody. Ready? 1, 2, 3, open source.
Open source.
Oh, that was so sad.
Oh.
No audience participation.
Oh, thank you.
Oh, I'm so excited to be here. Good to see you all. Hi, Doc. Hi, Cora.
Hello, great to be here.
Hi, everybody. You know, we're excited to be here. Super excited to be here. But we were a little anxious, I gotta tell you, about what we would say and what we would do and what we could show to best exemplify all the cool stuff we've been working on. And we thought, well, we could bring back the old pet clinic, you know, but that's a little tired. We've all seen that before. So we thought we could do something in the spirit of that, right? Something to sort of support the process of adopting dogs. We could put together a service for a fictitious dog adoption agency called Pooch's Palace. And we thought that would be pretty good. I mean, who doesn't love dogs? Everybody loves dogs, right? Everybody loves dogs. This is my dog. I don't like him. I like dogs. Don't get me wrong. Just not this one. He's a terrible, terrible dog. But he is very cute. And there's 2 reasons we keep him in my family. One, his name is Peanut. And there's 2 reasons to keep him. 1, he's very cute. And 2, is ego, right? In my family, my partner and daughter both speak 5 languages. I only speak 3.5. So if my dog was not here, I would be the stupidest person in my family. It's not okay, so we keep the dog. This dog reminds me of another dog that I learned about during the pandemic. There was a dog named Prancer. This person was trying to find a new home for Prancer. And she described the dog, and she said, the problem is there's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins, right? Let me see, demonic, Victorian, there we go. This one, at this point, she said, I am convinced that he is not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. So, not a good dog, but also even this dog deserves a good home, right? So we should build something to support that work. So what I'm gonna do, as always, so I'm gonna begin our journey here at my second favorite place on the internet, start.spring.io. I'm going to build a new service. And friends, we have some questions we need to answer before we can get underway. First of all, what do we want to call the service? I'm going to call it Service because I'm amazing with names. I'm great with names. I get that from my father. My father was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Very, very good with names. Amazing with names. That said, my mom, she tells me all the time, she says, you're very lucky that I named you. And yeah, that's probably true. Probably true. We're going to use Java 21. We're going to use Maven. We're going to use Java. And then we have some dependencies that we need. We're going to bring in the web support. We're going to bring in the Spring Data JDBC support. We're going to bring in the GraalVM native image support. We're going to bring in the GraalVM. Did that not add? There you go. JDBC. Hello, JDBC. Okay, and we're going to bring in some AI support. We want to make this easy on us, so we'll bring in some Spring AI, OpenAI support. We're going to need a SQL database and a vector store, so we can do 2 for 1 by using PG Vector Store. And for our architecture, we need Spring Modulith. Anything else? RabbitMQ. Let's add that as well. And then we're going to hit Enter and open this up in our IDE. CD downloads. Do I have 2? I have 2 for some reason. Take 2, here we go. UAO service.zip. All right, so now we're going to build an application that's going to connect to a database. Friends, I've already got that database running off to the side here, so I don't need to stand anything up, but I do need to specify how to connect to it. So localhost my database like this. Okay, and then Spring Data Source username equals my user. And then the password will be secret. Now I can just click on this little button here, get a nice connection dialog, hit OK, go over there, refresh. So click on that, refresh. And we can see we've already got a table there called dog, right? And we've got our pal Prancer down here, number 45. Now, we need to build an architecture, and I'm not really. Would you mind doing that?
I can take care of that.
OK, thank you.
Absolutely. All right. So, all right, let me just get quickly set up here. We want to build an application for, that's sustainable, right? That's the most important aspect here. So we need an application that's going to be easy to understand, easy to test, and easy to change. So we can use domain-driven design to start to identify our domains, meaning the key areas of our application that map to business functions. Now, if we want to keep these domains isolated and manageable, we could implement them as microservices. But if we're just trying to get clarity and modular and isolation at the design level, then taking on the challenge of distributed code bases and distributed deployments is a really high price to pay. So instead, we're going to create a modular monolith where every domain is a different module within the same code base. In other words, in the same Spring Boot application in this case. And Spring Monolith is going to help us implement these architectural concepts, and it's going to help us maintain these principles as the application evolves. So now we can start the video. I can't talk and type as fast as Josh. I don't know how he does it, so I have pre-recorded the demo. Okay, so one fundamental idea behind Spring Monolith is that each top-level package represents a different domain. So we're going to start by creating a dog domain. We're going to add a class called adoption controller, and this code is pretty standard, so we'll just paste it in. For simplicity of the demo, we're going to use a record for our dog aggregate. We have a repository to interact with the database. We can get a list of dogs. And we can post a dog ID and an owner name, and this method will write the new owner to the database and then write a line to the log file. So this is a good start, but most likely we're going to have different business functions that need to react to adoption. So for example, we might want to tell the vet, maybe schedule a checkup before we release the dog to a new owner. So let's go ahead and create this checkup class, but recognize that this doesn't belong in the same domain. So we're going to create a new domain called vet, and let's say we want to organize our code further and put this into a subpackage called scheduling. So we'll implement this for simplicity as a public static method, and we'll just write a line to the log file. So this should work, and we can try this out. We'll run the application, and we'll send a request. And let's see, we get a 200 back, so that's good. And so we see the owner in the database, and we'll see the 2 lines in the log. We have adopted and scheduled. So the code works, but the question is this good design? And Spring Modulith can help us answer that question. So Spring Modulith can build an in-memory model of the modules and their interaction with each other, and then it can apply an opinionated set of Arc unit rules, which means that we can write tests that will tell us if our application is well designed. So let's go ahead and do that. So first, we'll write this test, and we'll create an in-memory model of the modules first, and then we'll verify it. So we go ahead and run this test, and we'll see that it fails. So we have working code, but bad design. So that's good to know. And this error is telling us that the dog module is trying to access a non-exposed member of the vet module. So even though the Java compiler allowed it, Spring Modulith is saying that what we did was bad practice. And so in Spring Modulith, by default, top-level packages comprise the open API of a module, top-level packages, or but code in sub-packages, sorry, or in private packages is implementation. So we could fix this by moving checkup into that top-level vet package, but let's take a closer look at the integration between dog and vet. So these modules are tightly coupled, so any other module that wants to react to adoptions would be here in the dog code, and the dog would become a funnel for functionality and would become very difficult to test. So Spring Modulith encourages us to use application events for module integration, which is Spring Framework's in-memory messaging. So we'll add that to our code and application publisher. And of course, we need an event to publish. So we're going to create an event called dog adopted. And we'll use a record and pass it the dog ID. So now we can decouple the code and publish anything here. So any module can subscribe, and adoption controller doesn't even need to know about it, right? So keep in mind that application events are processed synchronously by default, which means this method has to wait for all subscribers to finish processing before it can close the commit boundary and move on to other code. And so Spring Modulith can help us customize this default behavior and make it more efficient. But that happens over on the subscriber side. So we'll hop back over to our checkup class. And we don't need public static anymore. We'll process the event. And so what we want is we want this listener to act asynchronously. We want it to start after the parent method finishes its commit. And we want it to start a new transaction to process this event. So Spring Modulith is going to make this really easy for us with a single annotation called application module listener. Now, of course, if we change the module interaction from direct calls to asynchronous events, we also have to change our approach to testing. So we'll take a quick look at an integration test that is written in an event-focused way. So you can see here we're using Scenario, which is a Fluent API that is provided by Spring Modulith to test the interaction of modules. So we're just basically saying when we take this action on this module, we expect an event to be published. Now, what about error scenarios? Could we lose this event? And in fact, we can, because we started a new transaction and this event is in memory. Now, I'm not showing it here, but with Spring Modulith, you can configure persistence to save and republish events if necessary. So before we run this test, let's consider one more scenario, which is that managing modular monoliths is easier than wrangling microservices, and it also makes it easier to modernize legacy code. But sometimes you do need to extract and deploy a module as a separate microservice, and at that point you need external messaging like Rabbit or Kafka or JMS. It's also true if you just need to share events with external systems. So here again, Spring Modulith is going to make this really easy for us with a single annotation that goes on the event. It's called @externalized, and I'm just going to add it here and then add some specific target annotation for Rabbit, which is running in the background. So now we can run this integration test, and you'll see that we have the event, both Rabbit and the other one, but you don't see in the log file any logging from the vet module. And that's because we've used another annotation at the class level here that Spring Modulith provides us to be able to load and test just one module at a time. So there are more features that I encourage you to check out. I'm just going to highlight one last one of them. So we'll go back to our modularity test. And Spring Modulith provides a documenter, which automatically converts the in-memory module into documentation. So you can see here, we'll run this test again, and it'll automatically generate plant UML diagrams that show you the model plus some metadata about key architectural concepts. So this is a very simple app, but of course, with more complex apps, you would get richer documentation. So now we have a well-designed, self-verifying, and self-documenting application that makes it more intuitive to understand and easier to test and change in the future. All this thanks to Spring Modulith. So, what do you think, Josh?
I think that's amazing.
Awesome.
We have the ability to adopt Prancer because we know of Prancer, but people who are looking to adopt a dog, they're going to have questions, they're going to need help making this decision. I think we should build an assistant to support that effort, and I think we should use Spring AI. Do you want to? Yeah. You want to? Well, I do.
All right, let's do it.
The AI does too. Do you want to tell us about that?
Yeah, sure. I'd like to introduce the topic a little bit. So we've all seen conversational chatbots online. That's in fact kind of what started the whole explosion with ChatGPT. So we're going to make a chatbot for adopting demonic dogs, which is not something you'd normally do, but we'll do it. So just to set some context, the topic of AI and computer science is not new. There have been many waves. This is what we'd call the generative AI wave. And there are some things that make it unique from previous generations. And this is what you should think of as kind of the pedal tone for creating AI applications. These are the features that you can take advantage of as an application developer, adding AI to your application. One of the first things is that human language is the interface, both for input and output. Very powerful. Another great feature is you can guide the model to take on certain personas, so to give it contextually relevant output, which is something we'll be doing today, as it can take on the persona of someone who owns Pooch Palace in Las Vegas, because it's a global company, as you well know. Generative is in the name, so it's very good at creating new stuff. In fact, it's so good it can kind of just make stuff up as we go along, and we'll get to that a little later. And what's most important, and why it's most relevant to people in this audience, is that you no longer need to have the skill set of what we call a traditional data scientist or AI engineer. And part of that is because all of this technology has been exposed with simple web APIs, and we all know how to make web API calls. So how would you go about, roughly speaking, creating an AI application for your enterprise? And the key thing to distinguish it is that you have your data and your APIs that the model has not been trained on. So the P in GPT is pre-trained, so it has a great large general knowledge base, but it doesn't know about your internal documents and your internal APIs because it's never been trained on it, despite, I'm sure, them trying to. And the other components in the landscape are all the models. You know, there's kind of an arms race going on right now in terms of all the different companies trying to create models that are the most powerful, or potentially smaller dedicated models that are very good at specific tasks. And even within a given company that's making these models, there are variations. So part of your task in creating an AI application is to evaluate these models to see which one is best for your specific use case. And another technology that kind of goes hand in hand with creating an AI application at this point is a vector database. There are many of them. Some are dedicated to this purpose. Some are sort of added on top of existing databases like Postgres. And in the middle is Spring AI that is trying to glue all of this together. And one thing that Spring is great at is integration. You can already access all of your data through some Spring project out there. Lord knows there's many of them. And so here's a typical scenario at a high level of what you would have to do to create an enterprise AI application that understands your data and your APIs. The first step is you have to load your data into this vector store. You know, the reasons of which we can't get into, but essentially it deals with the limitations of the model and how much data you can send it and the cost structure around sending that data. So if you're going to ask a question about Hamlet, you don't need to give it all the books of Shakespeare. It would be a waste because you already know most of that material wouldn't be relevant. And you store this information in a vector store, and now you have to connect your app to the model. But one great new feature that's evolved over the past year or so is that the models have essentially reasoning capability. So if you ask it a question, and let's say it doesn't really know the answer, you can provide helper functions. And these helper functions are essentially map onto calling your API. So literally you have the model, OpenAI in its data center, calling back to you to invoke certain behavior. If this sounds crazy and dangerous in some scenarios, yes, you're absolutely right. But that's what it is. You know, be safe out there. And once you look into the architecture, you'll see there are several challenges, right? And what Spring AI is trying to do is help you overcome these challenges. So for example, we need to align responses to goals. And there's a technique doing this with the system prompt. It's not trained on your data, so you have to bring your data to the model. One thing that people don't realize when they're starting off creating their own AI application is they're used to interacting with ChatGPT. ChatGPT is actually an application on top of the raw API, and it keeps state, so it keeps your conversational context at hand. If you're building it from scratch, you have to maintain that sort of chat memory state yourself. So there's another thing that Spring AI helps you with. And last but not least, you have to evaluate this. How do you know it's working correctly? This is not the case of running a unit test, seeing it's green, and moving on. The models change over time, especially the hosted models. And sometimes it really just makes stuff up because it really wants to talk. It's like having a hyperactive teenager. So evaluators are one of the techniques you can use to basically get a handle on if this is making sense over time. And right now, we've released version M2 of Spring AI. We've had contributions from over 70 people on the internet. So it's great to see such a collaborative environment. A big thanks to everyone who's listening, who participated in that. And one of the key focuses we had for this release was observability. So here are just some quick screenshots. The general idea, not that you can read everything here, is to see the flow of the calling stack that's relevant for your application. So anytime it hits the vector database or goes off to a model, you'll be able to see where in your execution, code is spending time, and part of the metrics are around the tokens. Tokens are essentially words. And usually in hosted models, you're billed by the number of words sent and received, and we count those tokens, and now you can make dashboards easily around cost, and you can drill down further to create dashboards that are appropriate for your metrics for your application. So with that prelude, I'd like to give it over to Josh to
Thank you. That's awesome.
start our small company, Pooch Palace.
All right, well, good stuff. So I think that's going to be a great fit for what we're trying to do here. Let's build a simple assistant. We'll go over here, close that, and I'm just going to build a simple assistant here called the Dog Adoption Assistant. Going to make this a configuration class. Can you all see that font? Should I make it just a bit bigger? How's that? Can everybody see that? Very good. Okay, let's say I'm going to build a dog adoption assistant. In order to do that, I'm going to have to talk to my model. And of course, in order to do that, I need a chat client. If you've ever used any of the other clients in the Spring ecosystem, this will feel very familiar. Now, the question is, how do I talk to my model? I have to specify a few things. First of all, I need to specify an API key. But friends, I've already done that off screen before I got on stage as an environment variable. So forgive me for not leaking my API credential. Just trust me, it's been done. I also need to specify which model I want to speak to. So I'm going to specify GPT-4o here. It's the flagship of the models, but there are many, of course. And with that, I can now start to ask questions and interact with the model. So let's go ahead and create a simple demo to ask it a very, very simple question. Okay? .prompt.user. Do you have any neurotic dogs? .call.content. Okay, and I'm going to assign that to a variable, like so, and just print it out. System out reply content. Okay, here we are. And make that a var because I can, and it's the right thing to do. Here we go. And there, let's just run it and see what we get. Now, I'm not expecting much of a response. Remember, there you go. It says the obvious thing, which is, hey, I'm an AI. I don't have pets. However, I can offer advice or information if you're dealing with a neurotic dog. Fair enough, thank you. But still, we want it to be a representative of Pooch Palace. So we need to give it a context so that it knows how to respond. So we're going to give that something called a system context, okay? And we're going to specify that here in the chat client itself. I'll say default system, and then pass this in, multiple line strings, thank you, Java. And it's going to say, you're an AI-powered assistant to help people adopt dogs from the adoption agency named Pooch Palace with locations in Las Vegas, Tokyo, Krakow, Singapore, etc. And if you don't know about the dogs housed in our particular stores, then return a disappointed response suggesting we don't have any available. So sure enough, I'm sorry, but it seems we don't have any dogs available that specifically fit the description of being neurotic at any of our Pooch Palace locations. Great. So it doesn't have what we want, but it's acting as though it should. You might be forgiven for thinking that you are talking to someone behind a computer that, for whatever reason, happens to just be offline at the moment, right? So it's acting in the persona of someone, okay? Now, we want it to be able to talk to our database. Remember, we have all those dogs in our inventory there, in our catalog, or dogalog, really, and we want to make it easy to connect that. So what we're going to do is take the data from our SQL database, as modeled by this dog repository that Cora built earlier, and then move it to our vector store. And the reason we're going to do that is because the vector store supports similarity search. So I'm going to say dog repository.find all for each dog, and then I'm going to, like this, and then I'm going to say var document equals new document, and I'm going to say ID, name, description. So I'm just providing a string-based description of all the important bits here so that I can put it in the vector store, okay? And vector store.add list.of document, okay? Now, this is a document for dogs, so obviously, document, okay? Very good. So now we've got this data in the SQL database in the vector store, but we need to make our model aware of that. This is a core part of AI engineering, is integrating your data and your APIs. And this particular pattern is called retrieval augmented generation, or RAG. So I'm going to write a advisor. I'm going to plug in a question answer advisor. Remember, this is going to be a whole RAG pipeline. This is not PHP though. I didn't wake up this morning and decide I'm going to write a lot of wasted, noisy, useless code. I wrote one line of code and I got a RAG pipeline. What did you do this morning? So here we go. Let's restart. Let it do its thing. And by the way, this does sometimes take a little while to do its job. Always a good reminder to plug in the virtual thread support, right? That gives you, there you go. Yes, we do have a neurotic dog available for adoption. Prancer is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. If you're interested in Prancer, please let us know. Great, I think, right? So we've clearly found our dog, but we need to make this in a format that we can use in the rest of our code. So I'm going to do some structured output, dog adoption suggestion, string name, string description, and integer ID, okay? So I want this to be the result that I get back from the client. So I'll say, first I'm going to comment this out so we don't reinitialize the system again. And then when I make the call to the client over here, instead of asking for the content, I'll ask it to be returned thusly, okay? So now I've just run the same query again. This time I get dog adoption suggestion, name is Prancer, description is demonic, neurotic, and there's the ID. So now we have an object we can pass around our APIs and use with impunity. But still, I think I'm ready to adopt this dog. I think I'm ready to, to take this one home. That said, I need to know when I can pick it up. So now we need not just to integrate our APIs, not just to integrate our data with our AI, but also to integrate our APIs with our AI, to give our AI model a little agency and a little executive agency here. So what I'm going to do is I'm going to create a function, okay? We'll go down here, and the function will take a dog adoption pickup time request with the name of the dog, and then a response with the time, okay? So pickup time. And we want to add this as well to our dog adoption suggestion. And we're going to create the function as a Spring Bean of type function. Yes, you guessed it, Java util function. Here's the request. Here's the response. Pickup dog adoption pickup time function, okay? Woo! Well, whatever. Pickup function. Thanks, IntelliJ. So here we go. Gonna say that, and there. And we'll just return a very simple object containing right now, basically. So new, there you go, instant.now.toString. Okay, and we need to make note of the name of the function. Let me make this a little smaller. It's getting a little crowded here. A little smaller, and then we're going to make note of the function and then tell the client it can use that function when trying to answer questions. Sorry? Oh, I need to provide the description as well. Good point. Thank you, Doc. We need to have a description, otherwise the AI won't know how or why it should use this function. This is a Spring annotation that's been in Spring for more than a decade. It's not new or novel to this particular use case. It's called @description. So with that, I'm also going to change the prompt, right? Because I'm now ready to take this dog home. So the prompt will be, when can I pick up Prancer? Okay, here we go. Ask the question, and then rerun. Hello world? Oh, I didn't, okay. Yeah, let's try it again. So dog adoption suggestion, time, 8:26, right? All right, so very clear, and we can try it again. We can print it out, to confirm it was there, like that. System out, hello, right? Do it again, one more time. Unreachable statement, oh, sure. Okay. Hello, thank you. And there's our pickup time. So with a minimum of effort, we're able to build an application that is now structurally sound, it's scalable, and we're able to architect our code cleanly, and now we're able to ask questions and get reasonable answers and integrate with our data and APIs to adopt our dog. I think it's been a pretty easy run.
Productive morning.
Well, thank you, everybody. Yeah. So obviously, this is just a taste of what's to come. Cora is going to be doing a talk called the Modern, this is a bit of a mouthful, it's the Modern Monolith with Spring Modulith. And that'll be at the Spring Theater, the Hub, Thursday, the 29th of August at 10 a.m. And the good Dr. Pollock and I will be joined by Spring founder, Dr. Rod Johnson, to do a talk on beautiful artificial intelligence, the Spring Theater, the Hub, on Wednesday, the 28th. I guess that's 2 days from now, at 1:35 p.m. Now, please, welcome back to the stage, the one, the only, the amazing, the inimitable Dan Vega. Thank you, everybody.
Wow, that was a power-packed demo, right? Thanks, Cora, Mark, and Josh. Remember, if you're online, you can join in the conversation in our Discord or check out the hashtag Spring1. Now, Netflix is one of the most well-known users of Spring. In 2018, they started using Spring Boot as their core Java framework. And even before that, the initial versions of Spring Cloud were based on the Netflix OSS stack. Now Netflix is running over 3,000 Java applications. With a history like that, it's always interesting to hear how Netflix uses and manages Spring. So let's welcome from Netflix staff engineer Paul Baker and senior software engineer Ossie Bras.
Thank you, Dan. We're so excited to be here today. We're going to talk a little bit about the benefit we at Netflix got from upgrading to Spring Boot 3. So, as Dan mentioned, we have over 3,000 applications powering a wide range of workloads, from streaming-based applications, studio application, enterprise application, and batch workloads like encoding and such. And these different types of workloads have different characteristics. Some, like streaming, might have high RPS. Some, like studio or enterprise, might have low RPS. Some are more sensitive to startup time, like batch workloads. Spring and Spring Boot caters to all these workloads, and we benefit highly from leveraging open source software like Spring Boot, because we can focus on our business logic and let Spring do the framework integrations. This is a very simplistic and incomplete diagram of the Netflix streaming application. As you can see, all those green boxes, these are all Spring Boot-based applications. These are mid-tier and back-end services powering the streaming use case.
So with over 3,000 Java applications, all standardized on Spring Boot that we have at Netflix, Spring Boot 3 was obviously a really big deal for us. And the main reason that we're really excited about Spring Boot 3 is that it kind of forms a reset for the whole Java OSS ecosystem. If you look at prior years, the Java OSS ecosystem was struggling a little bit to innovate because a lot of companies were still stuck on Java 8. And then we see the reasons to move to Java 17 and newer Java versions. And we also had to deal with the Java X to Jakarta namespacing. And while that namespacing isn't all that interesting from a developer's perspective, it was really hard for the open source ecosystem to support that split in namespacing and to keep moving forward. Now with Spring Boot 3, they've basically set a new baseline for the whole Java OSS ecosystem with a baseline on Java 17 and the Jakarta namespacing. And what we've seen now in the last few years is that now everything is moving super quick again. And then, of course, in Spring Boot 3, there's also just many useful and interesting features. A few things that we are excited about is the micrometer observation API, which is a really good abstraction on all things observability that we now use. And then there's things like virtual threads. If you're on JDK 21, which we are, you can start working with virtual threads. And I really believe that this is kind of the future of how we're going to scale our applications. And while work is still being done on virtual threads, it's really important that we start experimenting with it now, and that is now possible with the Spring framework. And then there's Spring GraphQL, which is now fully integrated with the DGS framework, which Netflix open sourced a few years ago to build GraphQL applications. And with this integration with Spring GraphQL, we can now work together with the Spring team to innovate in the GraphQL space. And there's just many small quality of life improvements in the framework as well. Things like better test container support. Test containers are really important for our testing strategy at Netflix. And these better integrations just make it easier to develop the applications that we have. And then, of course, a lot more is coming. Now that we're innovating so quickly again in the Java ecosystem, just looking at Spring Framework 6.2, for example, we get things like at test bean and background initialization. And while these are each kind of smaller features and they are not that big, they actually do provide a lot of value to us and provide us better ways to, for example, structure our tests. And then, of course, there's the big things like Spring AI, which just looks super exciting. Now, I've already mentioned JDK 17 and JDK 21 just now. And what I want to call out is that when we upgraded to Java 17 from Java 8 at Netflix, what we saw, kind of unexpectedly, is that we got about 20% better CPU usage. And that's just because of improvements in the G1 garbage collector. So that's the same garbage collector we used on Java 8. It's just a lot better on 17. There's a lot of improvements being made. And 20% better CPU usage, that's a lot of performance we get for free just by upgrading the JDK. And that's, of course, directly translating into cloud costs. And now that we're going to 21, we started experimenting with a generational ZGZ garbage collector, which is the new garbage collector in 21. And again, we see a lot of performance improvements, and especially when it comes to throughput. And then, of course, as a developer, you get all the new language features from the new Java versions, which just makes your day-to-day development just so much nicer. So lots of reasons to upgrade the JDK.
So we understand the benefits we're getting from both upgrading to Spring Boot 3 and adopting new versions of Java. But how did we go about at Netflix upgrading? We have a huge amount of applications running on Spring Boot 2. How are we moving them to use Spring Boot 3? So first and foremost, it's very important to be prepared for the upgrade itself. We wanted to make sure the applications are already on Java 17, which is a prerequisite for Spring Boot 3. We wanted to make sure that they're moving to the latest 2.7 release and making sure that they don't use any deprecated code that we know is going to be removed in Spring Boot 3. Aligning all these three just makes the application in a much better shape to do the upgrade. Of course, for doing that, we relied a lot on automation and sending automated PRs to kind of change the applications from using deprecated code to an alternative. From an automation point of view, we use tools, open source tools like OpenRewrite. OpenRewrite allows us to do large-scale automated source code refactoring. It comes pre-baked with a recipe, for example, for upgrading Spring Boot 2 to Spring Boot 3. We use tools like Codana from IntelliJ. This gives us a powerful code analysis functionality that we can then reuse existing inspections to do code changes. And we use our own tool like Gradle.lint, which is, by the way, open source, to do modification to our build.gradle files. It's important to mention that when after we built some of these tools, we went to our most difficult, bigger applications and said, all right, let's try to upgrade you to Spring Boot 3. And the reason is to kind of flush out any issues we have with our tools. And then after those got upgraded, the rest kind of had a more smooth sailing with the upgrade flow. One specific challenge and issue we ran into is with JavaX to Jakarta, and specifically with regards to libraries. We have many, many libraries at Netflix. Some of them don't even have owners. And having to expect a library that uses JavaX to also maintain a version that is Jakarta compatible, so it will work both for a Spring Boot 2 and a Spring Boot 3 application, is very challenging and time constraint from our developers. So we developed a Gradle plugin that does transformation on the spot from JavaX to Jakarta. So the library author will just write his library based on JavaX. That will work fine in a Spring Boot 2 application. In a Spring Boot 3 application, at build time, we will take those dependencies that depend on JavaX, transform them into a Jakarta-compatible one so that it will just work seamlessly in a Spring Boot 3 application. Of course, this is just for the time frame where we're upgrading the application from Spring Boot 2 to Spring Boot 3. Once we're completely done with this upgrade, we can then go back to those libraries and update them to use Jakarta. Once the upgrade's complete, we rely on our existing integration tests. Integration tests using Spring Boot that were already written, were compatible in Spring Boot 3 application, gave a lot of confidence that the change actually works. We use canaries. Canaries is when we shift a small percentage of our traffic to the new instances, and then we check that we didn't break any traffic or that we didn't degrade the performance of the application. And of course, doing manual validation to ensure that things work as expected. An important lesson from our journey is to focus specifically on upgrading to Spring Boot 3. We initially tried to pile in a couple more things. This just extended the overall effort we had to do. Spring Boot 3 is already complex enough with the Java 17, Jakarta, JavaX to Jakarta, and other major framework upgrades like Hibernate and such. So focusing on that already has enough complexity to just deal with that and not add more things. So what's next for us? We still have a few applications we need to upgrade to Spring Boot 3, the long tail that didn't finish yet. We tightly follow OSS releases. We're currently using Spring Boot 3.3, which is the latest that's released. We adopt Spring as they come out, both Spring and JDK, and leverage those features. Thank you all for joining today. Sorry, forgot one more thing. We have three other talks from Netflix. I'll be talking later today about SBN. This is our Spring Boot Netflix application framework built on top of Spring Boot. Paul will be discussing how to build a GraphQL service with Spring Boot, and also have another talk about the lessons learned from Netflix about effectively testing your application. Thank you.
Thank you.
That is us.
Hey, all right.
Are so good. This is awesome. My friend Josh gets to go and work on all the cool new stuff. I'm the new guy. I'm stuck. And imagine, if you will, there's an application that's running and the dependencies haven't been upgraded, or maybe there's even a CVE. Right? Your teammates are all working on the cool new stuff like dog adoption, and you're stuck with an app. This one's called Spring Pet Clinic. It was built way before I got here. I need to update it. There's CVEs, but I don't know where to start. I don't even know where it runs. Can you help?
Yeah, definitely. Let's take a look at the Tanzu platform dashboard. We actually have your application here, and I noticed that you have some vulnerabilities that are critical. Yeah, there's some end of support coming up as well on your open source libraries that you're using. Yeah, this looks pretty bad.
I adopted this app.
Of course, none of us use those older libraries, right? You're using Spring Boot 2.7. You haven't made the upgrade like Netflix just did.
Well, I would like to, but I needed to know where it's running first. So this is helpful.
Yeah, it's actually showing it's on Tanzu platform for Cloud Foundry.
I like this. I like this whole dashboard, and I'm wondering, do I only get to see that when I'm on Tanzu for Cloud Foundry?
Well, actually, we looked up things with Spring Discovery, Spring App Discovery, and we're able to see across your VMware Cloud Foundation and also your Tanzu platform requirements.
I got these pipelines from my good friend Marcin, and these pipelines are going, and they're going to apply these updates. So there's a plan there that's got 4 steps. Those steps are split up so that you don't stack bets like we just heard. The steps that are in that plan are set up so that you can run the recipes that need to run in order to get you to the next release, the next milestone. So here we've got a nice code review. Let's take a look. I see a governance starter. We'll talk about that later. This is all cool.
Jakarta to JavaX.
This is great.
We actually are able to automate that process with Spring Application Advisor right here.
And the pipelines created a new branch. I have a new branch that I can take a look at. So I'm going to go ahead and run some pipelines. I want to validate that branch. The changes that were just submitted by the Spring Application Advisor have been set up. I'm going to run those. This Spring Application Advisor is set up to be easily integrated into your CI/CD. So this is cool. So we looked at the review. We did a code review. We put code onto a new branch, and now we're validating that branch. That gives me a lot of confidence.
And the EDE test, isn't that doing a little canary deployment, doing a little test in the background?
Building the images with build service. We're getting everything up on new infrastructure. Yeah, let's go. Love it.
All right.
I have confidence. I'm going to hit this button because I want to go to production.
Let's merge it.
You want to go to production too. Let's take a look. This is cool.
Oh, wow. Looky here.
Making progress.
We actually don't have any more critical vulnerabilities.
No critical. My CISO can sleep a little bit better. This is good.
And also our end of support analytics, a lot better than before. Definitely got a little bit more time to get those upgrades going. Although we're going to keep going, right?
Absolutely. That's more. We're now on Spring Boot 3.0. We got a lot of cool new features. AOT.
Yeah, observability APIs, micrometer.
Native images is my favorite thing because the native images with Graal VM makes my Raspberry Pi go brrr.
Yes, so there we go. Good. Spring Boot 3. Here we already upgraded.
All right. I'm feeling good.
What's next?
I have access, but I want more. I'm ready to go. So because I have this as a part of my CI process, I've got a new plan. Now I only have 3 steps. I've got the recipes that will get me to the next milestone safely.
Yeah, it looks like we're going to Micrometer 1.11 and Spring Boot 3.1.
Fantastic. Shortly, I'll get a new branch with those PRs, with those changes, and we can go take a look at that code review.
Sounds good.
It'll be smaller changes. As you continue to do this frequently, regularly, as part of your CI process, these will be small. We'll take small changes to production, so we never have to look back.
Definitely. All right, there we go.
Code
Let's
review.
take a look at the files. Yeah,
Easy.
very small, actually. Just a little bit of configuration changes.
Looks good to me.
All right.
But I'm going to validate it with my pipeline. I'm still going to validate that entire branch of my pipeline. The old branch is gone. The new branch has been validated. This looks good. Let's take it to production.
Here we go. All right, I'm really hoping that our dashboard looks a little better. Vulnerability analytics, no
You know
higher
what?
critical.
This is good.
All right. But you remember that governance starter
The
thing?
governance starter, because, yeah.
Yeah, so actually one of the things that we also provide in Tanzu Spring is actually this new Spring Boot extension. And it actually generates an actuator output of audit information in case you're doing regulatory compliance, FIPS, PCI, whatever it might be. And it's showing here you're using the Bouncy Castle FIPS mode by default for all of your TLS. Ooh, wait a second.
I adopted this. This isn't my fault.
Yeah,
like that when I
your
got here.
application is not using TLS, or at least not validating at the application level. Let's take a look at the overall results.
Okay, so I have some work to do. Chris, I promise I will work on that because you can't have too much security these days, right? Nobody wants to be on the front page for the wrong reason.
Definitely. All right, so you're going to be doing that work, but the next step I think that we're going to take here is definitely get you all the way up to the most recent versions of Spring Boot.
Well, first of all, I have no more vulnerabilities. This is good. This feels good.
Definitely.
Thanks. This is good. All right, and it seems like we have some more stuff. Can we take a look at more?
Actually, I was seeing this other part of our dashboard that you might want to check out as well. Definitely less unsupported libraries.
This is good.
All right. Now we go over to the performance tab. This is where I get really excited. You know, you always have Spring Boot actuators enabled, and you have your metrics going out
Spring
of
Boot
those.
actuator.
We actually have in the Tanzu platform hub the ability to see these metrics real time. All right. So that information is coming in. You're able to see CPU usage. You're able to see response times. A lot of information that you get from those actuators.
So I don't have to go out and build new dashboards.
No,
I
you
deploy
don't.
my Spring Boot app to Tanzu platform for Cloud Foundry or Kubernetes, and I'm getting graphs like this.
Definitely.
This is amazing. But I'm not going to stop at Spring Boot 3.1. I'm going to take it all the way to Spring Boot 3.3.3 that got released last Thursday, right? Everybody's on that. And yeah, we're going to keep going. This is great. My automation's in place. I'm feeling good. Just ready to go.
And as the Netflix story told us, you know, not everything's ready for this upgrade process right away. But what we are willing to do is help you along the way. So even if you start with Spring Application Advisor, you start with the dashboard, it gives you a little bit of an indicator of how to get to the state where you're prepared to do these upgrades on a regular basis.
That's where I want to be. I think that's where you should be too. Continuous upgrades with the help of Spring Application Advisor, my favorite feature in Tanzu platform.
All right. And we
have some
actually have
sessions
a
later
couple
today.
of sessions that are coming up. Let's take a look. Stop receiving automatic PRs that break your builds.
That seems
And
really
so this will
relevant.
go a lot deeper into how Spring Application Advisor works, how you can use it on your own. And also we'll take a little peek into Governance Starter in more detail as well.
Fantastic. That was great. Thank you guys
Thank
so
you.
much for being here and for your
All
time.
right.
See you soon. Awesome.
All right.
Please welcome to the stage.
Hi everybody, happy to be here. In addition to my role in the Spring Framework team, I'm also leading the Spring Efficiency Working Group, which is working closely with other teams in the VMware Tanzu division on runtime optimization. So today, I'm going to talk about runtime efficiency with Spring and Tanzu platform. So let's talk about the most important question. Why do we care about runtime efficiency? The first reason is cost optimization. We all want to run our workload in a cheaper way. There are millions of Spring applications in the world, maybe 100 or 1,000 in your company. At that scale, technical optimization can translate to financial benefits. The second reason is sustainability. When you run your workload on cheaper server, usually you use less CPU, less memory, less energy, which makes running your Spring application more sustainable. And finally, we live in a world where usually you will deploy your application as containers. And with the JVM, that can be sometimes a bit challenging with startup time, memory consumption, and warm-up time. So we may want to optimize this. You can maximize the efficiency of running your Spring application by basically combining Spring Boot efficiency features with additional capabilities provided by the Tanzu platform. Today, I'm going to show a demo on Tanzu platform for Cloud Foundry, formerly known as Tanzu Application Service, But be aware that similar capabilities are also available on Tanzu platform for Kubernetes. There are different kinds of optimization. We can optimize the startup time, especially important on chip server when the startup of your application can take a long time. We can optimize the memory consumption by reducing the amount of memory that our applications are consuming and keeping the same level of performance. We can optimize the scalability, keeping the same throughput, same latency with less resources. Or we can just optimize the warm-up time, reduce the time required to reach peak performance. If we take a step back on Spring Boot 3 features, we can see quite a focus on efficiency. Spring Boot 3.0 introduced GraalVM native image support in order to compile your Spring application to native executable that start faster, consume less memory, but at the price of pretty high constraints. We also used to introduce Spring IoT optimization that we are going to cover a bit today. Spring Boot 3.2 introduced virtual thread support and Project Rack support. And finally, Spring Boot 3.3 introduces CDS support that we are also going to detail today. So what is CDS? CDS stands for Class Data Sharing. It's a technology that is already be used, most probably in the JVM that you are already using, but it's not used at its full potential. In order to use CDS at its full potential, you will have to do a training run for your application in order to create a CDS archive that will then be used for your production run to start faster your application and consume less memory. Spring Boot 3.3 introduced dedicated support for training runs, and Spring Framework 6.1 introduced basically also some support for loading CDS classes more efficiently. There is also Spring IoT optimization. So we introduced those optimizations specifically for native image support, and it's mandatory for native image. But be aware that Spring IoT can also be used on the JVM to optimize your application. Basically, by doing this IoT processing during your Maven or Gradle build, that will create an optimized configuration that will shift some processing that previously happened at runtime to the build time in order to start faster and optimize your app. Just by enabling a flag, and that's very important because that's a feature really easy to enable, just by enabling a flag, Tanzu platform and build packs, the technology that we use to basically ship application as containers, can perform automatically the training run, extract the Spring Boot native executable to a CDS-friendly file layout, ship the CDS archive within the container in order to have a self-contained container that will start faster. And optionally, you can also enable Spring IoT optimizations. So this is what we are going to see in the demo. So please switch to the demo. Demo, please. Yeah, thanks. So we are on the Hub UI of Tanzu platform, where we can discover the various applications of our platform. We have the Pet Clinic application that is using a Postgres database. The Pet Clinic application itself is the usual sample that we are using. It deals with owners, pets, veterinarians, and it's just a sample for regular middle-sized Spring application. We have previously deployed this application at Cloud Foundry on a very cheap one virtual CPU server, and it starts in a bit more than 10 seconds. On purpose, we are using a very cheap server that is pretty slow. We check also the memory consumption after startup. Again, without enabling this optimization, we are at 338 megabytes of RAM. And now we are going to enable CDS and Spring IoT optimization. So as a developer, I'm going back to my IDE. This is a regular Java Pet Clinic application with a Gradle build using Spring Boot 3.3. We are going to open manifest.yaml, which is a file that describes how our application should be deployed to Cloud Foundry. And we are enable those new features that are available in commercial build pack with Cloud Foundry. Here you see that we enable CDS, we enable IoT. So CDS is really just a flag. For IoT, it's IoT activation support, so it needs a bit more work, and I will need to enable the Spring Boot IoT plugin in my Gradle build, but you will see that's quite easy to do. And since IoT optimization are specific for a specific Spring profile, I will need also to fine-tune the configuration to specify that in production, I'm going to use my Postgres database, and I specify the related Spring profile. So let's go back to the command line. And we are going to rebuild our application with a Gradle clean build. OK? Yeah, could you bring back the demo, please? Yeah, so we have built our application with the 2 flags enabled, and our application is now being deployed. You can see that Spring Boot AOT is enabled at runtime. The CDS training run is performed automatically. All good. And then our application is going to be redeployed in order to publish those changes. And so we are going to check the new startup time, again, with just that flag that we enable, and we can see that now our application is starting in only 5 seconds. Thanks. Which is much faster with a very low effort. We check also the memory consumption, and now we can see that our application only consumed 251 megabytes after startup. So, let's go back to the slide, please. So the takeaway of this demo is that the combined usage of Tanzu platform and Spring Boot allowed us to make Pet Clinic startup time twice faster, reduce the memory consumption by 25% on a chip server using CDS and Spring IoT activation support. Of course, your application, it could even be faster. It really depends. But this is all with a very low amount of constraints. It's much, much easier to leverage compared to native image. And this is not the end of the story. The Spring team is collaborating with the Java platform team on Project Leiden. So Project Leiden can be seen as the successor of CDS that will bring even more benefits. And we are working with the Java platform team in order to potentially bring even more efficiency features to Tanzu platform and Spring. For example, even faster startup, smaller containers, and faster warm-up, some kind of ahead-of-time warm-up of your application to directly get peak performance when you start your JVM. If you want to get more details, come to see my talk tomorrow in the Spring Theater. The talk is Efficiency Container with Spring Boot 3, Java 21, and CDS. I will share more details. Thank everybody, and Dan, one call back.
Thanks, Sebastian. No matter how fast and efficient Spring gets, we can always benefit from more, right? If you're online or even here in person, let's hear what you've enjoyed so far in our Discord channel or by using the Spring1 hashtag. Now, hearing from people who use Spring is always thrilling to me. We heard from Netflix earlier, and now we're lucky to have Jürgen Sussner from Datev join our very own James Waters to discuss how Datev uses Spring. In addition to Spring, Datev has used Tanzu platform for many years. And I really appreciate that Jürgen has come all the way from Germany to join us today. So let's welcome Senior Director R&D at Tanzu, James Waters, and Principal Cloud Platform Engineer, Jürgen Sussner from Datev.
Thank you. Thank you. Super exciting to be here. And Jürgen, thanks so much for making the trip. And so fun to, right before we go on stage, watch a great engineering talk on how the framework and the platform are getting even better together. So I think, in my chats with you, you've got a lot of exciting news and results to share there. So let's just get started. Maybe first, you want to tell us a little bit about Datev and your role there?
Sure. Thanks for having me here. As said, I'm from Datev, Germany. Datev is actually the third biggest software company in Europe. Also, almost nobody knows about Datev. That's because Datev is a cooperative for tax consultants, auditors, and lawyers. And we create software for tax consulting purposes. And if you put all the tax laws in the world in a one big bucket, you get a choice of 1 to 3 that it's a German tax law, because German tax system is always complicated. That's why we need a lot of software. And we started with Tanzu platforms with Spring. We do it since 7-8 years for now. And we started as it was the pivotal Cloud Foundry platform in the former days, because we have a huge history of creating software. We started in the 60s creating software based on mainframes. We have software delivered on DVD to our customers' offices that runs there on their Windows PCs. We have classical Java Enterprise softwares. And we're now on the migration path of migrating all that software, even the mainframe part of the software, towards the cloud platform, towards a Spring-based ecosystem. And that's where are we at the moment. And that's where I am the technically responsible guy for all the cloud business, which is our on-prem cloud business because we are in a somewhat regulated environment and that we operate all these cloud platforms on our own in our own data centers.
Yeah, Jürgen, when I want to talk to you about the success you've had at Datev, one thing that really stood out from your advice was there's a consolidation towards these patterns in Spring at all times if possible. That's like the first stop, right? And you enjoy the network effects then of the team all knowing the same framework, et cetera. So maybe talk about that for a second, how you kind of got to Spring as a standard for that business logic at Datev.
Yeah, Spring enables us to simply focus on developing software. Spring and the Tanzu platforms as the ecosystem running all these just reduces the complexity of the data center, which can be quite complex, using all the load balancers and having at least 3 locations to be fault tolerant. With Spring, you can create an application, run it into production, and you can get the benefit of you build it, you run it approach without having to deal with all that complexity of the whole data center. So our developers do migrate all their mainframe applications, all their .NET applications, Windows applications, towards the Spring platform, and they just have to take care about the business logic, transforming this business logic, and the rest can be done by the platform. Even the services, that, like Postgre or whatever services the developer needs, they can be booked automatically in the platform. And I always used to say, the automation and the pipelining developers use for developing their application, the same principles do have to apply to platforms as well.
Yeah.
So these fully automation capabilities you get with Spring, you can also get with the Tanzu platforms to be able to patch your platform and your application as fast as possible, to get all the insights we just have seen.
Yeah.
This is really beneficial. That helps all the developer teams taking their responsibility for their applications because they get the right tools, they get the information they need at the time they need to take care of their applications.
Yeah, I think we all hear about platform engineering as this big trend in the market right now.
Yes.
And I think one of the things that Datev has done so brilliantly is they've really taken this idea of like, let's just focus on your business logic in Spring, and they've taken that all the way down to how they provision and update their data center. So when you use an app at Datev, the platform really understands all that metadata and is able to run and update itself in accordance with that. So maybe talk a little bit about what platform engineering means and how Spring and your platform engineering principles have come together.
As we started with Tanzu platform and tried to build up the platform, we thought about having the classical dev and ops separation approach.
Yeah.
We said, okay, we want to have an efficient platform for development, but operation of the application should be somewhere in an ops department. And we soon realized that simply doesn't work. It simply doesn't work not relying on Spring. Maybe we thought about combining classical Java Enterprise technology because we knew a lot about Java Enterprise with the Spring framework. But that doesn't work really well. So what we did, we decided to do the all-in on Spring. Spring is the framework that powers all our applications, that is the target platform for all our applications, and we need a suitable platform for these applications. And the best platform you can get, just we saw in the talk before, is this integration between platform and the application runtime, this tightly integration. A developer at our company, he creates an application, throws it on the platform, he gets metrics, he gets logs, he gets traces, he gets all the observability and insights he sees on that. And that is even possible for transformed mainframe applications.
Yeah.
And the fun thing about the mainframe applications is we have some experience porting even old batch jobs written in C on the mainframe, ported them to the cloud platform, to the Tanzu platform, and it even runs 3 times faster on the Tanzu platform as it did on the mainframe.
Yeah.
So the architecture Spring gave us and the blueprint Spring gave us allows us a lot more flexibility, speed, and performance with the existing applications.
Yeah, one of the things that you mentioned, but maybe we can dig in on it a little bit, is that now that you have the standardized framework, very standardized platform, that day 2 operations.
Yeah.
The one thing I hear from our most insightful customers is that day 2 operations becomes far more predictable when you kind of understand this stack that you're working with and you have an end-to-end solution. So what are some things that get easier on day 2 with this level of standardization?
Yeah, it's treating your platforms, your technology the same way you treat your application is this mindset of working with the platform as it would be an application, this fully automation. We have our platforms, and even all many of the day 2 operations for the applications itself are fully automated.
Yeah.
Like we saw on these maintenance capabilities, upgrading libraries is automated, also platform upgrading is automated. So if there is a patch to an application or to a platform that comes out, it gets rolled out immediately.
Yeah.
So we don't rely on LTS releases because we simply don't want to.
Yeah.
Our pipelines do patching of platforms and to some extent of applications fully automatically. If we don't stop them, a patch that comes out will be rolled out to production within 5 business days.
Yeah.
We have to stop them initially if we don't want that.
Yeah.
But it's the default, so we don't use LTS releases. And this level of maintainability and automation helps us in a lot of cases. And I tell this really often, but if you remember the Log4j approach, some years ago we all struggled with that. And what we did, we noticed it on Friday. On Saturday, we had the ability to patch the platform from the platform team side so that all Spring applications have been secured in a way. And we worked with the community to share our findings, to share our ways of securing these platforms we have. And what it also allows us to do, we fully upgraded all our platforms, and the platforms contain 20,000 containers at that time. We fully upgraded all the platforms 4 times in 1 week. And this is just possible.
Amazing. Just amazing.
And this is just possible with all the automation capabilities and all the standardized way of working with Spring applications. You don't have to care about the specifics of each and every application because they are based on the Spring framework, and we know how to deal with the Spring framework and with the runtimes underneath it.
Yeah, I think that's incredible. Like if you imagine the world we're headed to of this standardization at the framework level, the automated pull requests we saw from Chris to help you, continue to move forward, the inclusion of AI right into the platform so developers are able to readily access these incredible new language models and the way they can help with their applications, and then just down to this never-ending security posture and hygiene conversation where when you benchmark some of the slower moving organizations, they're taking many weeks to plan an upgrade or even think about Log4j. Meanwhile, every patch release of the Log4j vulnerability, you are bumping the whole platform forward.
Yeah, and it's the deal. We tell developers, you build it, you run it. Like we adopted the Netflix model, you build it, you run it. That's the way that it works perfect for us. But if you tell that to your development teams, you build it, you run it, just give them the right tools to be able to do this.
Yeah.
Give them a Spring framework which has all the abilities, give them the insights they need, the security tools they need, the ability of just booking additional services like with the Tanzu data services. That's all they need to take that responsibility.
Yeah, so in closing then, how hard was it for you to take a Spring developer and bring them to the Tanzu platform then? Like, what was the friction level on that?
I guess bringing a developer to the platform, the hardest part is not the technology itself.
Yeah.
The technology is really, really easy to use.
Yeah.
The hardest part is taking the fear of you're responsible for your application. But if you come from a siloed approach, dev to develop, operations to operate applications, then bridging that gap and telling, okay, here is the platform, hey, and it is easy to use. It is 24/7, 365 days a week available.
Yeah.
We take care for the platform. You just have to push your code and say, okay, here's the start, stop, restart button. That's all you have to do. And that is, you have to show it 3, 4, 5, 10 times that it works. And then it works for the developers as well.
They just start trusting that abstraction.
They have to trust the abstraction. And it's not about the technology, it's about taking the people with you on the journey.
Awesome. This is brilliant advice from Jürgen. And it's been a real privilege of mine to work with Datev over the years. And they really set a bar on standardization and automation that I hope we all can kind of continue to aspire to. So thanks so much for making the trip, Jürgen, and all the advice.
Thank you.
Welcome Dan back to stage to close us out.
All right, it's been a full morning, I know, but well worth it, right? We heard about the continued momentum of the Spring community, Broadcom's commitment to open source Spring, and why Tanzu platform is the best production environment for your Spring apps. We also explored Spring AI, Spring Modulith, how Netflix uses Spring, and their approach to upgrading and staying on the latest, greatest versions of Java and Spring. You also heard about the developer productivity and efficiencies Datev gained with Spring Boot and Tanzu platform. Sebastian was able to talk about the updates in Spring Boot 3 that enhanced runtime efficiency. And finally, you heard how Tanzu Spring does continuous upgrades and compliance at scale. All right, what is that one? That is not the one I was looking for, but let's, oh yeah, it was. All right, sorry. Let's talk about the rest of Explore. Check out all the Spring sessions that you can attend in the Spring Theater in the Hub throughout the week. If you're watching the streams online, you can see the schedule at springone.io/schedule. Don't forget, we've been talking about this Discord channel. There's a Discord channel out there. This is a really great way to stay connected with the Spring community. And if you're here in person, there's over 200 breakout sessions at Explore. I think you'll really like the talks in the Modern Apps track. For those breakout sessions, though, please check the Explore app. The seats in each session are reserved, so be sure to save the seat by adding them to your schedule. Also, if you're here in person, come see us, come see Tanzu at the VMware booth. We've also got many Meet the Expert roundtables and hands-on labs where you can engage with Spring developers, executives, and community members. All right, so don't forget the welcome reception tonight in the Expo from 5 to 7. There's also an Expo Bash tomorrow from 5 to 7 with drinks, free stuff, and lots of hanging out. Finally, we've got the big Explore party on Wednesday featuring Jimmy World on the main stage from 7 to 10. Please, if you get a chance, go ahead and take a scan this. I promise it's a good QR code. I know sometimes you worry about scanning QR codes, but I promise this is a good one. Just take a quick survey for us. Let us know how everything went for you. Okay, that's it for Spring Spotlight. We're going to take a short break. You can join us again at 10:45 Pacific in the Spring Theater and online for the rest of today's sessions. I really just want to thank our speakers, especially our friends at Netflix and Datev, for being here. But most of all, I want to thank you for being here, giving us your attention, and being part of this wonderful Spring community. Enjoy the rest of Explore, everyone.